guys, so today we're going to be talking about probability distributions. So there's a few things that I want to define for us first. So we have discrete versus continuous. So discrete is going to be something where we have values in our givens that can be, very straightforward. There's nothing changing about them. So for example, if we roll a die, we will always get either 1, 2, 3, or 4, 5, 6, something like that. Same with flipping a coin. You're either going to get heads or tails. There's nothing really in between that. So that's what discrete is. Now, if we had a continuous version, that's where things get a little bit more iffy. So, like time or height, where I could get 5.38 or 5.38261, anything like that. That means like the decimal could be really any number, as many decimals as I want between any numbers. Now, that goes into our sample space. Now, a sample space is kind of like the set of values that you could have. So, say my sample space for the die, that's going to be 1, 2, 3, 4, 5, and 6. For the coin, it's going to be heads or tails. For time, it could be any number between 1 and 2. Anything like that. So that's what a sample space would be. Now there's two characteristics of discrete probability distribution that we need to know. The probability of each event in the sample space must be between 0 and 1. So it's always going to be a decimal. Okay? And the sum of those probabilities that are between 0 and 1 is going to add up all the way to 1. It will not go over, it won't be under, it'll be exactly 1 each time. So let's get into this. So we have a bag of M&Ms from Joe and Phil, and Joe was upset to find that his bag had fewer candies than Phil. They decided to open 25 bags of candy and see how many M&Ms were in each bag. Here's our data. So we're going to make a frequency table. And a frequency table is really we're going to put the number of candies. So say our first one, we want to find the lowest one, is going to be 17. Now how many times did we find 17 in here? We only found it once. So the number of candies, 17, and the frequency of that was 1. And that's all. So now let's do 18, since that's our next number. So 18 was found 1, 2, 3 times. So number of candies was 18, and we found it a frequency of 3 times. Okay, 19. So 19 was found 1, 2, 3, 4 times. So we say 19 was a frequency of 4 times. Now I want you to pause the video here and fill out the rest of the table. So you're going to do 20, 21, 22, and 23. So pause the video here and fill out the rest of the table. So if you filled out the rest of this table correctly, you should have gotten the following values. So 20 had 8, 21 was a frequency of 4, 22 was a frequency of 3, and 23 was a frequency of 2. So the way to double check that is to make sure you've highlighted every single number, and I did, so I am all good. Now, number 2, we're going to use this frequency table to determine the probability of getting each number of candy in a randomly selected bag. So we're going to write the probabilities. Now you're probably thinking, okay, well how do we find the probabilities? Well, it's like I put my hand into a bag and I just randomly pulled out a bag of candies. I have a chance of the frequency out of the total. So that's how I'm going to find the probability. So our probability is found with the frequency over the total number of bags. So our total number, as it said earlier, was 25. So what we're going to do for 17, we're going to do 1 over 25. And then we're going to do the same for all of them. So 18 would be 3 over 25. 19 would be 4 over 25. And I'm getting the 1, 3, and 4 from my frequency table. Okay? Alright. So now that I have some fractions, what I'm going to do now is I'm going to find the decimal form. Now what I'm going to do is I'm just going to put that into my calculator. I'm just going to do 1 over 25 into my calculator. And when I do that, I'm going to get 0.04. Okay? So again, I'm going to take my next number, so 3 over 25, put that into my calculator, and I get 0.12. Then for 4 over 25, again, put it into my calculator, and I'm going to get 0.16, and so on and so on. Now, for the last 4, I want you to pause the video here and find those last 4. So pause the video here and find the last 4, fraction and decimal. Alright, so for 20, 21, 22, and 23, we got 0.32, 0.16, 0.12, and 0.08. So that's what you should get for your probabilities. Now, we have just created a probability distribution, so a table that shows all the possibilities for an event and the probabilities that go with each possibility. Now what we're going to do is we're going to add up all of the probabilities in our table, and I want you to do that yourself. So pause the video here, and I know I'm pausing a lot, but pause the video here and add up every single one of those probabilities, the decimals. So when you add up all of these probabilities together, you end up getting a whole nice clean number of 1. And that is true, and that is what we want. We want it to add up to 1. And that's how we know it is a discrete probability distribution. Alright, so let's answer the following questions. So how many M&Ms do you think the company says should be inside the bag? Explain our answer. So let's go back up to our frequency table. Now, when it says what we should say is the amount, that means what is the most common possibility that a customer will get this number? Well, the most common number is 20 right here. So we got 20 pieces of candy the most. So we should say for the company that we should say that the customer is going to get 20 pieces of candy. And that's because it's the most common answer number. Okay? So we can also express probability symbolically. So what do you think probability, so this means probability of x equals 19 means in words. So x equals 19, so that's going to be x equals number of M&Ms. So if it's asking for the probability that we will get 19 M&Ms, well, we know that. We already found it with this guy. So the probability of finding 19 M&Ms in our bag was 4 over 25, or otherwise known as 0.16. That's what we want. Alright, so moving on to C. So how can we write the probability of getting 20 or fewer M&Ms symbolically? Find this probability. So we're going to start with P. So P means probability, and that's what we're going to be using a lot in this unit. So finding the probability of 20 or fewer M&Ms. So we're going to have X in there as well. So 20 or fewer. So we want to get 20 M&Ms or anything lower than 20. So I think 20 should be going in there. And then 20 is going to be our greatest value or equal to it. And that's my symbolic representation. So now we need to find this probability. So we need to find the probability of having 20 pieces, 19, 18, and 17. So we know all of that, and we have it right here. So what I'm going to do is I'm going to add up those specific probabilities. So I'm going to add up the 0.04, the 0.16, and then the 0.12, and then last but not least, the 0.32. And I do realize I did switch these. So each of those represents the 17, 18, 19, and 20 pieces probabilities. And all we're doing is we're going to add them together, and that would be the probability of finding 20 or less M&Ms in a bag. So let's add those together. And when we take a moment to add them together, we get 0.64. Now, I'm going to point out that this represents 17, this represents 18, and this represents, actually no, this represents 18, and this represents 19, my bad, and then we have this representing 20. So that's where I got all of those numbers from. Okay? Now the other way to find it is if you didn't want to use the decimals, you could also use the fractions. Now what you could have done is you could have added up all the frequencies. So we could have did 1 plus 3 plus 4 plus 8, which is going to be, which is 16. And then we're going to find the probability using, again, this formula. We're going to put the frequency of it over the total number of bags. So what we would do is we would do 16 over 25. And if I were to put that into a calculator, again, I would get 0.64. So that's the two ways that we can do this. All right. Moving on. So now we have the probability of x greater than or equal to 22. So we want to express this probability in words. So I'm just going to use my arrows. So this is the probability. And then we have x is M&Ms. And then 22 is my number. So we need to remember that less than or equal to. So that tells me that x is going to be greater than 22. So 22 is the least amount of pieces that we can have, and anything above it will work as well. So this is the probability of finding 22 or more pieces of candy. Okay? Alright, so last question. What is the difference between at least 20 and more than 20? Express both. Okay. Express both probabilities symbolically, then find the probabilities. So at least 20 means that we are going to include 20 in our probability. So we're having 20, 21, 22, ... Whereas when we have more than 20, it means 20 is not included in this expression. It means 21, 22, 23, ... And my pen just freaked out. Okay? So let's express these symbolically. So we have the probability of x for both, and we're going to have 20 in each of them. The only difference, now I want you to pay attention, the only difference is this, is the equal to sign. Alright? So make sure you are really understanding those terms. Alright, that's it for today, and I'll see you guys next time.